All right, so for this problem, we're going to do some integration. So we will start by, first of all, we can factor out a common factor among these two terms. And that common factor that I can factor out is a 4. So I can rewrite it like that. And once I factor out that constant, that can go in front here. And so I have tangent squared y plus 1 dy. And so we don't have a rule for the integration or antiderivative of tangent squared u, but we do have a rule for other things. And we want to see if we can change this by using trig identities. And so let me show you the basic integration formulas. They are in the front of our book. So this is our book on the website. And if you click the ebook, at the top there's derivatives and integrals. And so if you take and you scroll through here, you can see some basic integration formulas. And we don't have one for tangent squared u, du. So, but I can use some trig identities to rewrite it into one of these forms. And so let me show you the trig identities. So there are a lot of places that you can find trig identities. You can just do a Google search for trig identities, and you'll find something that might look like this. Let me bring it to the page here. So we want to be familiar with some of these trig identities so that we can switch things around in calculus. And so there's quite a few listed here. The one I'm going to be looking at, when you have the squared terms, the Pythagorean identities are usually the ones to look at. Sometimes if you have double angles, there are double angle identities you'd want to reference. Here, let me pull that page back. So you want to find, here's the double angles that I'm referring to. So, but anyway, I'm looking at this right here. And so this one says tangent squared theta plus 1 is equal to secant squared of theta. And so that's exactly what I have here. I have tangent squared of y plus 1. And so I'm going to replace that, this right here. I can replace, it is the same as secant squared. So I can rewrite that like that. And so I'm just going to write this over to the side here. Tangent squared y plus 1 is equal to secant squared y, and that again is called the Pythagorean identity. And so now that I was able to rewrite it like that, now I can integrate this. And if I go to my integration list, let me pull that back. When you integrate the secant squared of u du, you end up with tangent u plus c. So that number 14 is the one we're going to use. Now remember, on the final exam for the trig function integrations, remember on the midterm you had a sheet at the beginning with the derivatives of some basic derivative rules. You're going to have some basic integration formulas on the final exam too. So these are not things that you necessarily have to memorize, but you do want to know how to use them. All right, so back to our whiteboard. And so we just saw that the integration of this, so would become 4, that's on the outside. And then this part here, integration of secant squared of y dy, becomes tangent of the angle y plus c. And so that's our answer in this one.